Hello, Tom from EveryStepPhysics.com, EveryStepCalculus.com. This is obviously a physics problem, right out of Yahoo Answers, or the students put these problems into Yahoo and a professor, somebody, retired professors or whoever, answers it. I'm going to show you how my programs that you can buy for $30 on my site of EveryStepPhysics.com, and you load 350 programs into your titanium calculator and you answer all your physics problems, okay? Just like what I would be doing here now. I'm going to show you in a second. A couple things about springs. This one doesn't really have whether the spring is vertical or horizontal or at an angle, but we're going to assume that it's a vertical spring because it says that it's oscillating up and down in there's simple harmonic motion, and it gives the mass, and it gives the spring constant, and it gives the amplitude. When they make a spring with a 200 Newton per meter constant, it has a certain strength, okay? When you hang a mass on the end of that spring, it pulls it down a certain amount, and that's by Hooke's law, which is force equals constant times the stretch. Now Hooke's law is F equals kx, x being a horizontal spring along the x-axis. And many professors still use that when they're talking about a vertical spring. I say that's not correct. I say it should be a y, because you're dealing with a y-axis now. Things like these that make sense doesn't work in physics for a lot of these professors. So anyways, Hooke's law, that would be force equals constant times k times y. And k is the SI unit for the constant, spring constant, okay? So let's do it. Now all problems have what you have to write on the side of your paper, like for instance on this problem here you'd put mass equals 2 kilograms, k equals 200 Newton meters, and amplitude A equals 20 centimeters. I do the conversions for you. They use professors and people that write these problems will have to trick you, see if you can be tricked into the conversions and supposedly use your mind for all the puzzle, and then the person with the best mind for that type of thing gets better grades or gets better scores. But anyways, all problems are like that. They have certain givens, okay? And so I take those givens and put it into a menu. I'm going to turn the calculator on here. And you'd go to physics in my, put physics in here in the entry line of the calculator, press enter, and up comes a menu. And we're going to scroll down here now to springs. And it's all alphabetical. You can see there's collisions in every aspect of physics. Potential energy, whatever you want to find here is in the menu, okay? So, but the problem is dealing with springs. So we're going to scroll to springs. There it is. And then we're going to choose vertical. And then we're going to choose what's given here, which is M, K, and amplitude. One quick thing about amplitude and stretch. One of the hard things that I had in programming these problems is they don't give you in the instructions or the books or anything else. Stretch is when is a calculation from Hooke's law, as I mentioned before, how much a mass stretches the spring when you put it on the end of it, okay? That's not amplitude. Amplitude is the amount you stretch it beyond the equilibrium point, okay? When you use Hooke's law to find the calculation for the stretch, initial stretch because of the mass, that's equilibrium. That's the point called equilibrium. Now, In these problems, they'll have, as I'll show you in a second here, when we find the amount of stretch, is that when they pull it down another amount of stretch, okay, to me, a spring cannot oscillate if it doesn't oscillate within that stretch, okay? When it goes back to the natural length of the spring, it just stops. It's too strong to oscillate back and forth, okay? So anyways, I'll show you that in a second. So we're going to scroll down here to, we got mass, and we got K and amplitude right here, MKA, okay? I'm going to choose that. And we're stretching, not compressing. And we're going to enter the mass, okay? You have to press alpha before you enter anything in these entry lines in your calculator, okay? So we're going to, and the mass is 2 kilograms, okay? Might be 2 grams, might be 2 inches, whatever, you know? So I do those conversions for you as they try to trick you in physics. And most of this stuff is algebra after you get into it. It's not teaching physics, it's algebra. Pulling something out of an equation and trying to solve it for that, okay? So we're going to press alpha, and we're going to put in 2, and we're going to choose number 2 kilograms. You can scroll down to that or use the number in front of it. Now we're going to enter amplitude, and we're going to press alpha 20, and centimeters, number 2. Notice I give you the formula for that. 20 times 0.01 is 0.2 centimeters to meters, okay? Spring constant, alpha 200. Newton meter. Sometimes they give you Newton per centimeters, Newton per millimeters, even foot pounds, okay? So I've seen those in problems, which I program. I always show you what you've entered. You can change it if you want. I say this is all right. Mass is equal to 2 kilograms. Amplitude is 0.2 meters, and the constant is 200 newtons per meters, okay? Say it's okay. Here's the stretch formula from Hooke's law. Force equals constant times y. We're going to have y. So we pull the y out using algebra, of course. And force is equal to mg. That's the force of gravity. Mass times gravitational constant, or gravitational figure, which is 9.81, okay? So we have, notice a little tiny stretch of that because of the mass that we entered on this into the spring, okay? 0.0981 meters, okay? Now if they asked you for angular frequency, okay, here we have the formula for that. Okay, you put this in here and you come up with 10 rads per second. They might ask you for the period, 2 pi over the angular frequency, so that equals 0.62832 seconds. Acceleration is amplitude times the angular frequency squared. PE is the total energy when you stretch a spring. 1/2 the constant times the amplitude squared equals 4 joules. That's going to always equal the kinetic energy because of conservation of energy and all that stuff that never really helped me in these problems. Kinetic energy, then the formula for that is so now we want to find the velocity, initial velocity. And so we'll use algebra to do that. And VI is equal to, I always like to give you what I'm talking about too. You'll notice that a lot of professors, when they answer stuff, they just put figures down here. You have no idea what they're talking about, you know. But in my problems, I'm adamant about that. Okay, so that equals, the velocity is 2 meters per square. Well, here's the answer then, 2 meters per square on the test, okay? Now also PE, if it was, PE is equal to mgh, which is, and we can find the h then by using algebra again, by pulling that out. And here's 0.20387. You notice that this is the same as the 20 centimeters down amplitude. But I say it can't go up that far because of the calculation we found for the stretch when you hang a mass on the end of the spring. So we can see the answers again. Press number 1, we can go see all the answers. I'll go through it quick. Okay. Yes, you want to see it again. Okay, fine. And pull out whatever you need for that problem. And then, of course, we press 2. We'll go back. We could do a new problem. We can go back to the main menu. Go back to the main menu and back to the physics menu. Go to my site, buy my programs, and pass physics. Have a good one.